Good morning, good evening, and good afternoon, everyone, wherever you are. Welcome to Winterstock, our week-long thrilling armchair spectacle hosted by Lenovo, NVIDIA, and Intel, where we bravely explore Lenovo's concept from exascale to every scale. My name is Carolyn, and I am your host today at Lenovo's Executive Briefing Center. And we will soon be exploring the topic of computational fluid dynamics accelerated with artificial intelligence. Ram Joganpalli, Mariusz Kolanko, and Marcin Rojek will be your presenters today. They will introduce themselves in a minute. The first approximately 20 minutes of today's briefing will be the formal presentation, with the last 10 minutes or so reserved for questions and answers. So if you have any questions along the way, please make sure to put them in the questions tab, and we will answer them at the end of the session. We'll be recording this briefing, and the recording will be available in the next 48 hours for replay. Okay, Ron, our global lead, would you like to kick this off and have a quick introduction?
Thank you, Carolyn. Appreciate it. I am Ram Joganpalli with Lenovo. I'm the global lead for manufacturing CAE vertical at Lenovo. Today we have an excellent computational fluid dynamics presentation, as Carolyn opted to. And we have one of our great partners, byteLAKE. And presentation will be by Marcin, who will be the CEO and co-founder of byteLAKE. So we are working closely with byteLAKE, where byteLAKE is leveraging Lenovo's Artificial Intelligence Innovation Center to basically accelerate the application of complex AI algorithms to further accelerate the computational fluid dynamics, productivity, the ROI, and time to market for enterprise and small and medium-sized customers. So that said, before I turn it over to Marcin for his exceptional presentation on CFD, I just wanted to cover a couple intro slides on Lenovo. Next slide, please. So Lenovo is a global technology leader with a very strong manufacturing footprint in 36 facilities. Although the world knows Lenovo as a #1 in PCs, but ironically, Lenovo is also a leader in high-performance computing, specifically in artificial intelligence and IoT, with multiple awards as seen at the bottom of the slide. Next slide, please. So Lenovo proves its technology prowess by being one of the leaders as a supercomputer provider with almost 180 systems out of 500, which is quite remarkable, with almost 35–36% market share and #1 in processing cores, which speaks quite a bit about Lenovo as a technology leader. And it's one of the most diverse companies and having a truly global footprint. Next slide, please. So this slide is probably the most relevant to what Marcin will be talking about, because Lenovo is a leader in high-performance computing markets, but specifically in high-performance computing with convergence happening with AI. A lot of our competition, they kind of try to repurpose their HPC product line, but at Lenovo, we work with partners and develop and offer integrated solutions into AI and the IoT market, specifically into manufacturing and various other verticals. And this is a very distinct feature coming out of Lenovo and working with great partners like byteLAKE. So Lenovo also takes its supercomputing abilities, and as Carolyn mentioned, going from exascale to every scale, we offer differentiated solutions into high-performance computing and AI, and offer a truly convergent solutions portfolio. Next slide, please. So without taking too much time, we have a lot of accolades for what we bring to the market, but not only as a technology leader, but more importantly, as solutions and integrated solutions working with partners such as byteLAKE. And this is where market recognizes us, which is where customers adopt Lenovo products. With that, I would like to introduce Marcin, who will be presenting the computational fluid dynamics. Marcin, please take it over.
Thank you, Ram, for the introduction. And yes, indeed, we as a company, we're very happy to work with Lenovo, and we heavily utilize Lenovo's data centers and especially innovation centers to build products powered by artificial intelligence. Today on the call, myself, Marcin, and Mariusz Kolanko, we're both from the founding team of byteLAKE. And as Ram and Caroline mentioned, we will talk about AI accelerated computational fluid dynamics. So what is byteLAKE's CFD Suite? A couple of key features I would like to emphasize. So first of all, the ultimate goal of the product is to accelerate CFD solvers, like traditional CFD solvers, with artificial intelligence. And people always ask us, so what acceleration actually means in your context? So first of all, the time to results is significantly shorter thanks to AI. So you get better speed up with, and the speed up is way better than through hardware acceleration alone. And in other cases, it might mean that we reduce the number of iterations until you get to the final state. You cut down on time until you get, but anyway, the goal is to get the results accurately and faster, way faster than just upgrading your hardware infrastructure. Augmentation of numerical solvers with complementary AI models. That means that you can, since you can run your simulations much faster with AI, then you can eventually reduce the time and the cost of trial and error experiments. And with that in mind, I would like to also emphasize that CFD Suite is 100% completely compatible with existing toolchains, and we are, and the numbers of tools or CAE tools with which we are getting compatible is growing every couple of weeks. Solver-specific AI models for digital twin industrial scenarios. That's the goal here, is to be even more accurate and be able to generalize the AI models so that they can handle simulation across different geometries, parameters, values, and so on and so forth, so that you have one model for one solver able to handle different configurations. And designed to speed up. That's the alternative to what you would normally do with optimizing your CFD solver or adapting it to hardware acceleration, which is the very significant effort. In our case, it took us 1 or 2 years to adapt a complete solver to the new architecture. With AI models, we are able to deliver accelerated solver within 2 to 4 weeks. And moving forward with the presentation, how it works. So CFD Suite follows the traditional workflow in a way that you still do the modeling. So you prepare the architecture of your, let's say, phenomenon. You prepare the geometry. You prepare all the border condition, collectively known as modeling. And then you send the data directly to your solver, which iteratively or in time steps generates final results. A process which usually takes anything between hours to weeks. With AI model from CFD Suite, you do exactly the same at the beginning. We take data one-to-one, so there's no additional overhead for you to transform the data to anything else. You just send the data as you would normally do to your CFD solver simulation. Instead, you get the results much faster, which are again 100% compatible with your visualization tool, and then you can move directly to simulation analysis, visualization, and analytics. A process will be explained in more details next. Of course, we have a roadmap, and Mariusz,
yep,
you can comment here.
Exactly. So a few words about the roadmap, which is really important. It's worth to highlight here. So you can you know where we are currently. So currently with the CFD Suite, we are able to simulate 2D and 3D domain simulations. This is something that is already happening. And right now we are cooperating with the partner that is 3Diagonal solution, but have the tool named Mixit. And with them, we are preparing the solution for chemical mixing. So yeah, as you can see on our roadmap, this is the CFD simulation framework, solver-specific AI models, and integration with our partners. So this is something that is already on board in our product, and we can have really tangible results that we will show you later in this slide. But it's not enough. We have a plan already to go beyond this thing what we currently have, and we would like to accelerate also other solutions that are already on the market, including also the open source projects. After that, we would like also go beyond one node simulations. So we would like to use a big cluster for training. So to do this, we will go above 2 million cells meshes, and we know that going to the cluster, it will allow us to go more than 2 millions, up to 5 millions, and more than 10 million cells, up to even 100 million and 200 million cells. What other we would like to achieve? So we would like to go beyond the premise. So we have in our roadmap also going to the cloud with the solution, and of course, when we are there, we also thinking about going even broader in our plans. So we don't want to focus only on one solution like mixing chemical, but we would like to have let's say generator or AI model. So whatever you will imagine in solving the problems in simulation, we would like to prepare the model for doing that. And of course, when the product is mature enough, we will prepare the channel partnerships. So we would like to establish a so-called program for partner. So of course, with that program, our partners will be able to offer our solution to the market. What's next I can say on our roadmap? Will be integrate our solution with the LICO. This is something that you can see on next slide. So LICO is a tool from the Lenovo. It's intelligent computing orchestration, and we would like to also integrate our solution with the LICO. Why? Because currently we are working with partners, tridiagonal one. But further in our roadmap, we would like to also establish another partnership with another client. And we know that LICO is really good solution for achieving this goal, because with this orchestration, we think that it will be a really good tool connecting our solution with the solution of end customers. Thank you. We can go further. Yes, typical steps to get started. So Marcin, will you tell a few words about that?
Yeah, so basically how to start with CFD Suite. So first, of course, naturally, you need to pick the solver that you would like to accelerate with artificial intelligence. And typical simulations that become candidates here are the ones that obviously take too long. And we have simulations that take 4 hours, which is not acceptable by some customers, but we also have simulations that take like weeks. And then we organize a conference or a quick consultancy session where we need to together set the expectation level. So the first expectation level is around acceleration. So we need to understand what acceleration means for you, whether you want to reduce the time, iterations, anything else. What's the accepted accuracy versus traditional CFD? Should we generate the results of the final step of the simulation, or should we also somehow simulate the intermediate steps, and which? And then, of course, we also need to understand your data, which data you send to the traditional solver, which ones you receive at the end of the simulation, what's the data format, what are the ranges, and so on and so forth. So this one is usually discussed during the first consultancy session. And based on that, we prepare the model which we train currently on our side. And as Mariusz mentioned, we have it on a roadmap to integrate our tool with orchestration tools like Lenovo's LeCO, where we will fully automate that process and also make it available to our clients. Currently, we do it ourselves for clients, and then at the end of the day, we deliver the trained AI models. And the goal here is that the CFD Suite will be 100% completely compatible with your workflow. So there will be no need in infrastructure changes, no need to change anything regarding the data formats, no additional wrappers, no additional overhead on your side. All right, and then, so what are the typical deliverables? So AI models, as mentioned, are compatible with existing workflows. Sometimes people ask us, okay, we don't have yet the AI strategy, so can we still use CFD Suite? And the answer is, of course, you can. The same way as you use AI-powered iPhone or Android device, you don't need to make any changes in your platform. Our tool is cross-platform. It works on CPU-only architectures. It works also on CPU plus GPU. We have a roadmap for beyond data center, so also cloud. And then there is absolutely no hardware upgrade needed on your side. And then the models are easy to use. So the deployment is pretty straightforward. You just, as mentioned on the previous slide, you just send the data instead of your traditional solver. You just send the data to CFD Suite. You get the results, minimum 10x faster, and then the solution is highly adaptable to follow the changes in your CFD solver. So if you modify your CFD solver, you change the configuration, you change the flow, or you change the algorithms, the model in worst case scenario can be retrained to adapt to new changes. But if you just change parameters or configuration or border conditions, the model can handle them very well. And enabling new possibilities, mainly much faster simulations, so lower costs of trial and errors experiments. So these are the main benefits our partners and clients say. To sum up this part of the presentation, ultra-fast results, driving costs down, eliminate expensive hardware adaptations. So as mentioned, within 2 to 4 weeks, we're able to produce new solver for you, which is 10x faster at least. And then real-time simulations for some. We're having discussions with some clients who want to run simulations that take, instead of minutes or tens of minutes, to reduce that to seconds. And then lower entry barriers. So if you ever try to start with CFD simulations and you don't have, let's say, enough bandwidth or muscles within your organizations to get trained with tools, whatever, and then to prepare the data, we can guide you that through either through the network of our partners, or we can give you the solver which is trained for your particular case. And plug and play. No need to change anything on your infrastructure. You just take our solver and simply redirect the data flow. Let me move further. And then there's a mailing list where you can contact us to get more information about the product and the roadmap. There's also a community available on LinkedIn and on Facebook where you can join the interesting discussions. And few links, and as Caroline said, the presentation will be available for on demand. There's a LinkedIn group, there's a Facebook group, and there's a blog post series as well, where we share more information as we progress with development. There is also a dedicated website where you can find all the details and download our brochures. Let's go to the benchmarks, because that will be the most interesting and I think thrilling part of the presentation. And Mariusz, why don't you go back to the stage?
Yeah, thanks, Marcin. So probably you are interested and you would like also to show you how it works, what are the results of the first benchmark. But before that, a few words about the hardware that we use. So the solver that we used for our benchmark was a chemical mixing. It was a steady state algorithms, and with the less than 2 million cells meshes. Hardware configuration that we used for inferencing, this is a standard desktop CPU only, one i7, and of course for training it was really a huge machine. It was two-node Intel Xeon Gold processor with NVIDIA V100. and all those things was done in Lenovo Data Center. So thank you, partner, for that. So on the next slide, I will show you how it works. So with the traditional workflow, what you are doing, so after modeling process, you are starting the simulation. And of course, it's taking a really long time to finish. What is going on with our solver? So after modeling process and starting the real simulations, because our solution is data-driven, so we need at least one small piece of the real simulation to predict what will be at the end. And in our benchmark, we did 3 different scenarios. We did scenario for the fast, medium, and accurate models. And you can see on this slide, for the fast result, we need only 3,2% of the simulation. After that, we are going to the data formatting, so that after the simulation, we can go to our CFD Suite process. And when our tool is done, then we reformat the data again to have the result. And all those process, all the total measurements was up to 28x faster than the normal simulation. So as you can see, we need only 3,2% simulation to predict the end result. And as you can see, the accuracy of that result is about 82% of the accuracy. On the next slide, you will see the medium solution. Of course, the traditional solver is the same, but in the medium mode, you can see that we need 6,4% of the real simulation of the real solver, so that at the end we will get much better accuracy than we have in the past. Of course, something for something, and with that simulation we can have only up to 14x faster results. And as you can see, everything depends on the simulate that we are using at the beginning. So the more simulation we did from the traditional solver, the better accuracy we will have. But it means also that the results will be achievable, and it will be more in time. And with the after medium, we have also accurate model. And as you can see, to be really accurate, and accuracy in this model is 93% of the accuracy. So we need almost 10% of the real simulation. But with the 10% of simulation, we will be faster than 10x, faster than simulation from the traditional solvers. At the next slide, you will see how it really works, and it is the output of the real tool from our partner, from the trigonal solution, and the tool is called Mixit. And this is how it looks like, and Martin will tell you something more about the results in the tool.
Yeah, so as you can see, we have a different configuration of the models: accurate, fast, and medium. And then on the left-hand side, at the top, you see the result of the real simulation for the chemical mixing. As you can see, we see here a tank with a propeller centrally positioned, and the fluid is poured into the tank, and the mixing process starts with some initial conditions like the RPM level, certain viscosity, certain liquid level. And to the right and at the bottom, you see how AI handled the prediction. And we predict different parameters here. And for example, for X-plane velocity, we see the deviation, which is way below 1%. So as you can see, the accuracy is around 99%. And also visually, we see hardly any changes and the critical areas around the propeller is actually very good predicted, right? And then here, as mentioned in the previous slide, we reduce this time of simulation from many hours to just minutes. On the next slide, we'll show some other parameters like pressure. For example, here the deviation was slightly higher, like 1.4% with AI, and then still the results were very good, even for the fast simulation concerning the critical areas. And then beyond that, we have some turbulent parameters like turbulent kinetic energy, where we also see really good accuracy around 1.5% deviation. And then for other parameter, which was in that simulation quite tricky, but AI handled it pretty well, and it's called epsilon. And then the deviation, we started with double-digit deviation, but then we went down to below 1% as we fixed number of things in models and so on. So in general, CFD Suite is a collection and combination of models, and they are picked for different parameters, but collectively for the whole solver, you just get one model, which now is able to handle different combination of parameters. So you can freely change your RPM level, viscosity, liquid level, and so on and so forth, and then still get results we presented. And the last slide here is that for a different experiment we did, you see also a comparison for X-plane velocity, pressure, and turbulent parameters. And the values here look like this, but as you can see, the deviation done with CFD Suite, so AI prediction, was on a pretty good level. And percentage-wise, the deviation was roughly around 1%. And this simulation required 5 time steps or 5 iterations to complete the simulations, and that was for the chemical mixing. As mentioned, presented tool is called Mixit, the one that we used for CFD simulation. AI part was done by byteLAKE's CFD Suite. Everything we trained using Lenovo's one node configuration, but we are right now working heavily on going beyond one node, so there'll be MPI on top, and we'll be able to address larger mesh sizes. And that leads us to the Q&A session. So if you have any questions you would like to ask at this stage, feel free to send them through the channel right now. If not, here are the emails where you can reach out to the team, both on Lenovo and byteLAKE site, and we can also discuss offline and organize a demo on demand.